Within a competitive environment, manufacturers will be pressured by changes in consumer habits that are demanding more transparency in production and supply chains and decreasing profit margins. However, manufacturers' shop floor often contains a lot of MODA, or non-value added activities, such as materials waiting, people moving, overprocessing, excess production, and so on. This is a result of batch production with long lead times, production lines with unbalanced operations, and inadequate and non-economic layouts, which may impact productivity by as much as 20%. To maximize activities' added value and improve productivity and service level, a flow improvement model should be adopted based on the principles of one-piece flow and synchronization between production and logistics. The one-piece flow model can be achieved by designing lean production lines and optimal work sequences from raw materials to finished goods. A lean production line breaks with the batch production paradigm, typically based on a functional layout, and looks like a U-shape. It uses less surface, generates less work in process and defects, while having higher flexibility. In a lean line, work is balanced between operations, although mutual aid is encouraged, enhancing teamwork and flexibility. To deal with activities execution time and quality varying among employees, a careful work analysis should be carried out. Standard work can help. It is a 5-step process to identify and eliminate waste, leading ultimately to standardization and employee training on the best sequence of operations. Process consistency guarantees targeted results and is a good foundation for flexibility and automation. However, it is not enough to improve flow in production. The flow paradigm must cover both internal and external logistics. The challenge here is to synchronize logistics loop and implement an information flow that follows the material at all stages. The traditional pattern of material flow inside a factory is based on the taxi model, where forklifts transport pallets from one station to another and from raw materials warehouse to finished goods warehouse. This model is complex to manage, consumes a lot of resources, human and equipment, and has high safety risks. The new paradigm for internal logistics optimization is based on a logistics train, also called Mizuzumashi, that executes standard cycles to move materials inside the factory, which significantly improves productivity and accuracy. To excel in manufacturing operations, the material has to flow according to customer needs. It is hard to synchronize material with information on an informal basis. Standard information flow needs to be created, starting with customers' orders that should be converted into production and transportation signals on the shop floor. To leverage the improvements in production lines and logistics train, the information needs to be available at the right place and right time. A flow transformation inside a factory has the power to optimize resource efficiency while improving service through flow efficiency. The key metric impacted is productivity, with gains of around 30%. The benefit can even be higher in cases where lean is combined with digital, reaching savings of 40 to 80%.